Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Okay, welcome to another installment of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'm the host of the Automotive Diagnostic Podcast. And today we are going to be talking about airbag diagnostics. What I want to do is run through a couple case studies. The second vehicle, maybe not so much a case study. It was a pretty simple, straightforward fix, but I spent a little extra time with it just because I was curious about the circuit and how it was designed. So we'll talk about the details of how it actually works, rather than so much the diagnostic. The first one we're going to talk about is actually one I made a bad call on, which I think is really one of the best ways we can learn, myself especially. When you screw up something, you tend to not forget it. It tends to really stick in your brain for future reference. So thought I'd share that one with you. But I've been seeing a number of airbag diagnostics recently, so it's top of mind, and wanted to share that with everybody. So the two items that we're going to be talking about today is the airbag crash sensors or impact sensors, the sensors that actually, they do what their name says, is to detect impact when the vehicle's in a collision and send a signal to the airbag control module to say, hey, set off the airbags, set the deployment loops off. And that's actually the second component that we'll be talking about, is the deployment loop circuit itself, not so much how the deployment loop works. We get it. It's going to go boom, it's going to set off an airbag or a pretensioner or whatever it might be, but more on the diagnostic side, how does the control module monitor that circuit to make sure that it's intact? Because unlike a lot of components under the hood or elsewhere in the vehicle, the control module can't perform a active test on these components, on the deployment loops, the actual airbag modules and the pretensioners. It can't test those to see if they're working properly. So it does need a way to determine, is this circuit going to work when it's needed? Because, I mean, if you think about it, a vehicle can be on the road 15, 20 years and never have the airbag set off. That control module needs to know, though, that in the event that it does happen 15 years after the vehicle's been built, that everything is going to work properly, that the circuit's intact. And what goes into that is actually pretty interesting, and that's what the second case study will be talking about. Okay, before I get into the details of these vehicles, the first thing that I want to bring up, and I'm sure you know if you've worked around any of these systems, but just in case you're unaware, or just a reminder, is you do need to be very careful around these systems when you're working on them. Number one, I would follow all of the manufacturer warnings and recommendations around testing or working around these components. Most of the time, this involves disconnecting the battery. Now, I can say that I don't always necessarily do this, because sometimes I do need the circuits live. I need them active, but we still need to be taking safety precautions when we're working around the actual airbags themselves, the pretensioners, and including, this is one of the most important ones, if you are working around the control module itself. GM always calls this the sensing diagnostic module. This is the guy that decides if the airbags are going to go off or not. And one of the things that can happen is, if you are working around this control module, physically moving things apart, unbolting things, and you unbolt the module, you remove it from where it is on the vehicle, latched down, bolted down, and you start moving this thing around, you flip it over while it's plugged in, you have a very strong potential of setting off the airbags in the vehicle. So if I'm going to be working around a control module, I'm going to be very careful. And I'm going to disconnect the battery unless I absolutely have to have it active, for certain testing. But my warning is just be careful around these systems, because we absolutely do not want to set off airbags. Not only because of the cost to repair, these things aren't cheap, and a lot of times maybe the airbag will come out and tear the dash apart, but personal injury as well. If you're sitting right in front of one of these things and it goes off, you can get seriously hurt. So do be very careful if you're working around airbag systems, so that does not happen to you. With that being said, we're going to get into the first vehicle here. One that I looked at recently, 2009 Chevrolet Silverado. This was the 4-door extra cab pickup. The shop called me in. They had a code setting in the airbag module, which turns on the airbag light on the dash, a B0087-00. So a lot of these codes we're seeing, this isn't even that new of a vehicle, but in newer vehicles will have the standard OBD2 format, and then they'll have a subcode. In this case, the subcode was 00, and I'll get to what that is in just a moment. As far as previous history to the vehicle, they had replaced the driver's side rear door for some body damage, and they also replaced the sensor, the impact sensor in that door with a GM part. And that was in attempts to get rid of this code, but the code remained. So that's when they called me in to come check this out. And so I get into this, and I want to know what the code actually means before I start digging in. So if we look up a B0087-00, our possibilities, the definition for this code is a short to ground, short to power, or an open, which isn't extremely helpful in this case, because I'd like to have a little bit more direction than that. But what it is indicating to me is there's a circuit problem somewhere in this circuit. This is, again, the crash sensor, the impact sensor on the left rear door, driver's side door. It's a 4-door pickup, the door that they replaced, and the control module is basically saying there is either a short to ground, a short to power, or an open on this circuit to this sensor. So I think the first thing that, and I'm somewhat familiar with these, but I'll share it with you. The first thing that we want to know is, how does this circuit normally operate? And GM's actually pretty good in the service info of explaining how this circuit works, what's actually happening on this circuit. So this is a 2-wire sensor. It goes from the control module out to the sensor in the door. There is a blue wire and there is a green-black wire. That's it, just 2 wires. So not a whole lot to deal with there. On that green-black wire, there's a ground. Okay, so one of the wires to the sensor is a ground. On the blue wire, this is where all the action happens. This is going to be pulsed 7 to 8 volts. I've seen a variation. And this is true for a lot of impact sensors, not just General Motors. I can't say it's true for every single one of them out there, but I've seen a number of them that are like this. So the control module on this blue wire, when everything's working correctly, sends out 7 to 8 volt pulses in short windows when you first key up the vehicle. And what the control module is actually looking for, and it defines this in the code definition, it's looking for a current change from this sensor. So the sensor is actually a tiny little control module in itself, and it is able to alter the current on this circuit from the 7 volts that's being sent out to it on this blue wire. So the 7 volts to power up the sensor, the impact sensor, but it's also being changed. And if you really zoom in on this waveform, you can actually see there's a little, I'd call it a sawtooth pattern in the voltage, but what's really changing is the current. Now we're talking milliamps, under 30 milliamps of changes in this wire. So it's very minimal, but the control module can actually pick this up, and it will register certain things like the ID of the sensor, the state of health of the sensor, and any impact commands. Okay, we just got into a crash, set off the airbags. So again, key up, the control module will send out a pulse of 7 volts to this impact sensor, and the impact sensor responds by changing the current on the wire, and the control module expects this response. If it does not see anything, if it does not see any current change, it stops putting out this 7-volt pulse. And actually, I should say it tries maybe 3, 4, 5 times. You'll see it pulse, 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 pulse the 7 to 8 volts. If it does not see a response, it stops sending out that 7 volts for that key cycle. It will set a code, most likely the one that we have here, our B0087, and it will not try again until the next key cycle. So you turn the key off, let it go to sleep, turn it back on. It's going to try to communicate with that sensor again, and if it doesn't see anything, just stops putting out that 7 volts. If it does see what it wants, what it's expecting to see from that sensor, you get a constant 7 volts on this wire. It's just straight 7 volts all the time. Then there's communication with the sensor that says, yep, I'm okay, everything's good with me, and no, we're not in a crash, or yes, we are in a crash. And that's really what's going on. So it's a power wire, but it's also a communication wire. And that's our blue wire. And then we have a green black, that's a ground. So fairly simple circuit once you understand what's going on, what you're looking for. So the first thing that I do is I go to the sensor. The rear door panel is really easy to pop off, and I knew they had worked back there, so I wanted to inspect, okay, what could have been done here. I took a look at the door jamb wiring, just a quick visual, seemed to be okay. And the sensor, I checked the wiring because they said they changed the doors, like, well, maybe the harness is wrong. The wire colors matched, and the sensor, again, was new. This is from General Motors. The shop had replaced this sensor in attempts to fix this code, same problem. So the first thing that I do is I want to see, am I getting this 7-volt pulse to this sensor? So I actually take out my little U-scope. If you've ever used the U-scope or seen it in action, it's totally worth your money. This thing is awesome, quick. I use it more than my voltmeter now just because maybe realistically it is a voltmeter with a screen, but you also get the scope function, and you can do so much with a single channel scope. And heck, this thing's only $150. I'll tell you what, I'll put the link to the U-scope from AES Wave in the show notes. If you don't have one, spend the $150 on just the basic kit, and they have an advanced kit as well. But even just the basic kit, that's all I have. It's so worth the money. It is such an awesome little tool. Anyways, this isn't about the tool. I hook up to this circuit, and I'm expecting to see, when I key this thing up, the 7-volt pulse to this sensor from the control module. Well, I get nothing. There's zilch on this circuit when I turn the key on. So my next thoughts are, okay, I either have an open or I have a short to ground, which are two possibilities of this code. The definition of the code says short to power, short to ground, or open. So one of those is the case. And I did check the ground on the green-black at the sensor. I did have a ground on that green-black sensor. I have my ground, but I don't have my 7 volts there. Time to figure out why. Again, I did a visual inspection of the wiring harness from what I could see in the door jamb. It all looked okay. Checked the pin fit at the connector. Everything looked all right there. So I'm going to move on. I want to go to the control module itself because they had actually already had the center console kind of tore up. And the control modules are generally, for airbag systems, are going to be located centralized in the vehicle, a lot of times under the center console, just because it needs to be attached to the body of the vehicle in case there is a collision or a rollover. It can sense that, and it's a good spot for it. So it was easy to access this control module because they already had part of the center console torn apart for me. So I want to start my testing there and see what I have or what I'm missing. So I find my blue wire that goes from the control module to the sensor, and this is the one at the sensor that I did not have my expected 7-volt pulses. So I back probe this wire at the control module, and I want to see, is anything different here? And I back probe it at the control module, and I don't have that 7-volt pulse at the control module either. Now, I'm not so much suspecting an open in this wire because, yes, I didn't have my expected voltage at the sensor, but I also don't have it at the control module. My next test is I want to see, do I have any pin fit issues or do I have any power or ground issues to the control module? I can talk to the control module. Obviously, I've got the code out of it, but that doesn't mean there couldn't be a power or ground issue. I disconnect the battery. And I touch the cables together, allow capacitive discharge, get everything out of this system so that I can now safely work around this control module, because I'm going to unplug this thing. And I don't want the battery connected while I do this, so I'm just going to be safe about this. So I disconnect the control module after the battery's been disconnected, and then I actually reconnected the battery at this point because I want to do some power and ground checks. But again, I don't want to be wiggling around. I don't want to be bumping this control module with the battery connected. So I took an extra precaution here just to be safe. So now my situation is I have my control module disconnected and I have the battery reconnected so that all my powers and grounds are at least going to the module. So I check my ignition wake up, good. I check my constant power, and I think there was a couple of them on this control module, good. And I'm using a 9000 series headlight bulb to verify that I don't have any voltage drops going to this control module. So my constant power is good. My ground, I had 1 or 2 wires that I checked my grounds, those are good. Everything seems to be there for the module to be awake and active. And I was able to talk to it with a scan tool. There were no other communication codes in the vehicle, so I'm not worried about the CAN lines in this case. So my last check to make is that the pin fitment on the blue wire, because again, I'm expecting to see my 7 volts coming out of there. I'm not seeing anything. Oh, and I should actually go back and mention, I tried clearing the code a few times while I was checking this circuit just to see maybe the computer has shut this circuit down because of the code, and that didn't seem to make any difference. From what I've seen, if there's an issue with the circuit, like I mentioned before, you turn the key on, it'll pulse it a few times and then stop if it sees the problem. In my case, there was never any pulse no matter what you did. Clear codes, cycle the key, didn't matter. So back to where I'm at in the testing. Now I have the pin fitment for this light blue wire, great pin drag, everything looks intact. So far, I haven't identified exactly where my problem is, but everything I've checked up till now has been okay. So the last thing that I want to do is I want to make sure that this light blue wire is not shorted to ground somewhere. Because if that light blue wire were to be shorted to ground, that would explain why I'm not seeing a 7-volt pulse when the computer's trying to. It would immediately see, okay, current draw is too high on this circuit, and I'm not even going to try. I'm just going to set this code. So I actually ohm checked this light blue wire from the light blue wire to ground, and I get, oh well, okay, so this thing is not shorted to ground anywhere, which is awesome. And again, this is with the control module unplugged when I did this test. And maybe I'll give you a little hint. This is where I messed up, and I was not thinking this through entirely and how I actually made a bad call on this one. But again, sharing this stuff is I think important, and understanding why you made the mistake or why you missed what you missed, it helps you in the future, and maybe it'll help somebody else out there as well. But anyways, I continue on, and I'm pretty confident what I'm finding so far. So my light blue wire is not shorted to ground. I did actually ohm check the light blue wire from the control module out to the sensor. It was good. And again, ohm checking, yeah, there's limitations to it, but this is a very low current circuit. This is not anything that needs to supply a high amount of current. So if I get 0 ohms, if I get continuity, I'm happy. I know that wire's not open. I had OL between it and ground, so it's not shorted to ground. I got all my powers and grounds to this control module. Must be a module. Okay, so I make the call, tell the shop, order up a control module. I'll get it programmed for you. We'll get you on your way. Okay, so next day, control module's there. I head back to the shop, program this thing, boom, bam, ready to get out of there. And the same code comes back after I program it. And I'm sure just about everyone's been in that scenario, not necessarily this exact one, but when you're pretty confident about the repair and it immediately just slaps you in the face and says, nope, you did not do this right, you effed something up. That's just the way it goes. That's life. That's our line of work. You make the wrong call sometimes, and hopefully you can learn from it. So here's what I learned from this one. I'm looking at this, and again, even with the new control module, there is nothing coming out of this light blue wire. there is no 7-volt pulse. And I checked the other circuits just to verify to see what it looks like, because I'm just going off of past experience, and they all have the 7 volts that comes on as soon as you key it up, and it stays steady because those sensors are communicating. And now I'm wondering, okay, is it the sensor? What's going on here? Here's what I forgot to check for after thinking about this for a little while, because I was like, it's not in the control module, but it's acting very similar to a short to ground, which is one of the possibilities for the code. I'm not thinking open. It's not a short to power, but short to ground, that kind of seems like what's going on here. But I ohm checked this wire to ground, and it did not show up as a short to ground. It was OL. My meter didn't beep at me. So what's going on here? What did I miss? Well, here's what I forgot. When I ohm checked that blue wire that goes from the control module to the sensor, when I ohm checked that to ground, I had the module disconnected, the control module. So where this wire actually was shorted to ground, where this wire was shorted to ground was actually the other wire on the sensor, the green-black wire, which is the ground wire to the sensor. But that wire is only grounded when it's plugged into the control module. So when I had the control module disconnected and I checked for a short to ground, of course it wasn't there because the green-black wire's ground was taken away. Had I done that check, had I ohm checked the blue wire to ground with the control module plugged in, I would have got a different result. I would have actually shown a short to ground because the ground that it was shorted to was coming from the control module, if you can follow that. Basically, the two wires were rubbing up against each other, and what I ended up finding was in the harness, outside of the line of sight, I had to completely take it out of the back door. They had done a repair poorly. They had done a repair to these wires, and they had not insulated them well, and the blue and the green-black wires were actually rubbing up against each other. The ground for the sensor was shorting out the power supply to the sensor. So anytime that module tried to apply 7 volts, just got pulled right to ground. Control module set the code right away. It was doing the right thing. I made the wrong call. So that's, again, just the way it goes sometimes. You move on and you try to learn from it. And I think that's the most important thing when you make a mistake is how can I learn from this? How can I be better next time? So I thought that was just an interesting case study. Not that it was that difficult to solve. Maybe it was for me, but just thinking about how the circuits work, what the codes mean, and the different ways to check them. But anyways, short to ground, because the two wires were touching each other, set this B0087 in this side impact sensor. So that's my first case study. The second one that I want to talk about is the actual deployment loop itself. And what I mean by deployment loop, the actual airbag. In this case, it is a side curtain module. And this is a 2013 Nissan Versa. I get called in. The code is B1129, which is a right-hand side airbag module circuit is open. And like I mentioned before, this one was not the most difficult one to solve. This is actually pretty straightforward. Went into it, and I immediately went to the airbag curtain module because you just have to pop off one panel to get to the connector. Well, it turns out the connector had been damaged. Looked like someone had been in there before, was messing around with it, damaged the connector. It was not connected to the airbag, the actual deployment loop, the actual curtain airbag module just wasn't connected. So told them fix the connector and you'll be good to go. But I actually had some time with this one, and which I don't always have, but sometimes I get a little extra time with the vehicle, and I'm a curious person. I was looking at the different codes that this particular circuit could set when I was looking up the 1129 to see that the circuit is open. This has some other codes for just this airbag module. Now, this is the case for all of the airbag modules on the vehicle. And when I say airbag module, I'm not talking about the control module. I'm talking about the actual airbag itself that it's going, or in some cases a pre-tensioner or something like this, but we're talking about an airbag. But airbag module is the terminology that's used. But there is a code for the circuit being open. That's the one I had, and it was just unplugged, so easy enough to figure out. Nothing special there. But there is also a code for a short to power. There is a code for a short to ground, and there is a code for the circuits shorted to each other. What I was curious about is how is the control module able to do this? And so I did a little messing around with this. So I had the deployment loop unplugged, okay? So this thing was already open, but I had the connector disconnected from the actual airbag. So I have no concern of the airbag setting off when I'm doing this testing. I have the battery connected, I have my scan tool connected, the keys on, all that stuff. But I'm really curious about how is the computer actually monitoring this circuit? So what I did was I grounded each wire individually. So on this circuit for this curtain airbag, there is a red and a green wire. Simple enough, okay? In the event of a crash, one is supplied power and one is supplied ground, sets off the airbag, the squib in the airbag, and goes boom in the event of a collision. I applied a ground to each one of these wires, the red and green wires, individually while this is unplugged. And with each one, and I'm clearing codes each time, but with each one, I was able to get a short to ground code. Okay, so try to follow me, if you will. There is a ground wire that goes to this deployment loop, and there is a what would be power wire in the event of a collision. And on both of those, I can set a short to ground. Okay, how do you get a short to ground code on a ground circuit? That's what kind of interested me about this, because I was just messing around to see what codes I could set and how it was monitoring the circuit. I shorted the two together just with a jumper wire, and it sets the code that they're shorted together. I leave them open, and it sets the code that they're open. So I was, again, just curious on how this works. So I hooked up my scope to it, and I wanted to see what is it actually doing on this circuit to be able to tell all these different things on these two wires that, again, are just a power and ground wire to a deployment loop to set it off. And this goes back to what I had originally mentioned in the beginning of the podcast, is that these circuits need to be monitored very closely anytime the key's on, but the computer can't activate the airbag to see, hey, is it working? It's not like an EGR valve where you can just do a self-test on it while it's rolling down the road. That doesn't work, so there needs to be a way that these control modules can monitor these circuits. And bias voltage is the key here. What I ended up finding out was, with this connector unplugged and looking at it with the scope, and I had two channels set up, one for the red wire, one for the green wire, power and ground circuits to this deployment loop. There was a 1 volt bias on both of these wires, individual. So again, this is unplugged, and these are coming from the airbag control module to the airbag itself. And each one of them had a 1 volt bias on it. So that's how it's actually able to tell if either of those wires is shorted to ground, because it needs to know, are either of these wires shorted to ground? Even the ground wire, if it were to be shorted to ground, it's going to pull that 1 volt bias all the way down. Control module is going to see that. Same thing on the power wire. So that answers my question. Okay, so it's able to tell each one can be grounded because of an individual 1 volt bias on each. But it doesn't answer the whole story. How can it tell if they're shorted together? How can it tell if they're open? If you watch on the scope, and I don't know how else you'd be able to see this, you wouldn't be able to catch this with a meter, but if you watch on the scope, and I'm going to put this pattern up, I'll put a link to it in the show notes in case it's tough to follow on audio, but I'm going to do my best to explain this. There is about a 5 millisecond window that repeats itself where a 5 volt pulse is sent out onto the power wire, the positive wire, I believe it's the red wire, and then there is a ground for the same window of time that is pulsed onto the negative wire. Okay, so again, both wires have a 1 volt bias, and for 5 milliseconds, the control module, the airbag control module, pulls one high to 5, pulls the other one down to ground or very close to ground. So it's actually sending out 5 volts and ground to this airbag control module for a short period of time. And this is part of the monitoring for circuit integrity as well. And for this short window of time, it's treating the circuit kind of like a thermistor circuit, if you want to think about it this way. So follow me inside the control module here. And I use a thermistor circuit, engine coolant temp sensor circuit, just because most technicians are pretty familiar with this. And I'll tell you, if you can figure out a coolant temp sensor circuit, which I'm sure most of you have, also known as, a voltage divider circuit, this is so important. It can be used on so many different areas of the vehicle when we're talking about circuit integrity monitoring and things like that. It's really key to understanding so many different aspects of the car. But follow me inside the control module here. So we're inside the airbag control module. We send out 5 volts, a 5-volt reference, into a high ohm resistor, which is inside the control module. I'm just guessing at the resistance. It doesn't really matter. Let's say 10,000 ohms, just a guess. It could be anything, but it's a high ohm in order to keep the current in the circuit low, even if it were to be shorted to ground. It's extremely high ohm resistor so that we aren't damaging any circuitry. So again, 5-volt reference, current limiting resistor, high ohm resistor. There's a voltage sensing circuit after that resistor, and that's so the computer can see what's going on the circuit. Now that wire leaves the computer, and it's going to go out to another resistor. If we think about our thermistor circuit, that's a coolant temp sensor. In this case, it's actually the deployment loop in the airbag system. It is the second resistor in this circuit, and then it goes back to the computer to a ground path. And so in the case of a coolant temp sensor circuit, we change the resistance of that coolant temp sensor, and it changes what the computer sees on that voltage sensing circuit. Between the two resistors, that voltage will change based on the temperature of the coolant, and the computer correlates that voltage change to the temperature or whatever it's measuring. But in this case, really what we're just looking for is a fixed voltage. When the computer sends out this 5 volts across the high ohm resistor, and then it expects it to drop across the airbag squib, which is just a resistor, it expects it to drop a certain amount and see that on that voltage sensing circuit if everything is plugged in. And again, so this is happening during a 5-second window, a little pulse. When it stops doing the 1 volt bias on both, and that goes 5 and ground, it expects to see a drop to about 100 millivolts after that high ohm resistor. And that's, again, if you just think of it like a thermistor circuit, that's really all it is, except we don't have a thermistor, we have an airbag squib. So if those two wires are shorted together, you're basically taking that second resistor out of the picture. It would be like unplugging your coolant temp sensor circuit and putting a paper clip between the two. And if you were watching on the computer, you'd see 0 volts, because that's what the computer is seeing after that high ohm resistor. All of the voltage has dropped across the first resistor going to ground. And you'd see coolant temperature skyrocket to 280 or whatever the max is. In this case, we're not looking at temperature. It's just looking to see, did we get the voltage drop that we were expecting in the circuit? So if those two wires are shorted together, it sees 0, says, okay, this is shorted together. If it is open, it's going to see 5 volts on that wire. Same thing if you were just unplug the coolant temp sensor. It would go to -40, you read 5 volts, no current flow, no voltage drop. None of the 5 volts drops across that high ohm resistor. So really it's just quickly in 5 volt pulses treating that airbag squib like a coolant temp sensor in a way, in a thermistor circuit. And that's how it's able to tell, is it open? Is it shorted to each other? But again, this is only a 5 volt pulse, and this happens repeatedly. Pulse, 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 pulse. And while the times it's not being pulsed, again, it goes back to a 1 volt bias on both wires, and it's able to tell is either one of those shorted to ground. So this is pretty intricate stuff here. And if you didn't quite follow all that, I don't blame you. It's tough to do that via audio. Take a look at the show notes. Find the link to the scope captures that I have, and it might make a little bit more sense. And I'll label those and I'll put those up there so you can take a look at them. But I just found it very interesting how intricate these circuits are, and what we're dealing with as technicians, because unfortunately they don't always lay all of this out in service information. Some of it's proprietary, especially when it comes to airbag stuff, because maybe companies don't necessarily want to have that information out there for legal reasons, how their circuits are being monitored. But if we're really thinking about just basic electrical, we can figure out what the computers are doing, and it can apply this to a lot of other circuits in the vehicle. It doesn't have to be an airbag circuit. I don't think any other circuit is as highly scrutinized as airbag systems, again, because it's a safety critical item, but I don't see why they can't apply this to other areas. And actually, now that I'm thinking about it, there was a Scanner Danner video a couple of years ago, maybe, where he was working on a Volkswagen evaporative system, and a heater pump actually had kind of a similar bias voltage pattern with some pulsing going on. And it may have been something very, very similar to this setup. But I thought that those were both two interesting stories to share. So if you're still listening at this point, you're really into this stuff. You're a nerd like me. So I want to say thank you for listening. I really do appreciate it. Hey, here's the other thing too. If you are liking this podcast, you're enjoying this, and you have something that you'd like to add or that you'd like to talk about, maybe you have a case study, or maybe you have something that you're interested in, hit me up, and I want to get you onto the podcast. We can set up an interview, and I can do that remotely. We can make it pretty painless, and I'd love to talk to people because, like I mentioned at the beginning of the podcast, I've got some stuff to say, but my knowledge is limited, and so I want to hear from you. I want to get the experts on this show. That's one of the main goals here. So you can find me on Facebook, Sean Patrick Tipping. Just send me a message. I will respond to you as quickly as possible. We'll draw up an interview outline, and then we'll have a chat. So other than that, thank you so much for listening, and hopefully you'll tune in again soon.